Then we did questions based on moles, how to calculate moles. The first formula to calculate number of moles is number of atoms, molecules or ions divided by Avogadro's number. What is the value of Avogadro's number? Right. So over here, this formula is based on the definition of mole. What is the definition of mole? 1 mole of any substance is any particles of that substance, that is 6.022 into 10 to the power 23. So this is the definition of mole. Like dozen, what is the definition of dozen? 1 dozen of any substance. 1 dozen banana means 12 bananas. 1 dozen pencil means 12 pencil. So dozen is representing a number, that is 12. Similarly, mole is representing a number, that is Avogadro's number. So 1 mole of atom means these many atoms. 1 mole of molecules means these many molecules. 1 mole of electrons means these many electrons. 1 mole of ions means these many ions. So this is the first definition of moles. So Na particles, it can be atoms, molecules, ions, electrons, protons, neutrons, for which you are calculating moles. So Na particles of that will represent 1 mole, right? So 1 particle of that will represent 1 by Na mole. N particles will represent N by Na moles. So this is the first formula to calculate number of moles based on the definition of mole only. So we have done questions based on this. Like suppose there are 6.022 into 10 to the power 24 molecules of carbon dioxide. Then how many moles of carbon dioxide are there? How will you find out? So these are number of molecules. Divide this by Na. We will get the number of moles of carbon dioxide. So we have done questions based on this. So any doubts in these type of questions? So these questions are based on this formula. From number of particles you are calculating number of moles, and from number of moles you can calculate number of particles also. Like suppose there are 2 moles of water. So how many water molecules will be there? 2 Na. Or you can write down 2 into 6.022 into 10 to the power 23. That's it. So it is based on this formula. Then the second formula to calculate number of moles is given mass in grams divided by molar mass or molecular weight of that substance. So this is based on the definition of molar mass. What is the definition of molar mass? Mass of 1 mole of the substance is definition of molar mass. So suppose the molar mass of any substance is mW. So mass of 1 mole of the substance is mW. So molar mass is always expressed in grams. So what is the unit of molar mass? Grams per mole. It is written like that. So mass of 1 mole of the substance, it is always expressed in grams. Molar mass is of 2 types, gram atomic mass, gram molecular mass. Now mass of 1 mole of the substance is mW grams. So by unitary method, 1 gram will be how many moles? 1 upon mW moles. So if there is W grams, that will be how many moles? W by mW moles. So this is the second formula to calculate number of moles based on mass of the substance. So mass of the substance divided by molar mass of the substance. Mass of the substance should be always in grams. If it is given in milligrams or kilograms, convert this into grams. So based on this formula, we have done some questions like what will be the mass of 2 moles of carbon dioxide? So if you are having 2 moles of carbon dioxide, mass of 1 mole of carbon dioxide is 44 grams. 2 moles will be into 2. Now if the mass is given, how will you calculate number of moles? Suppose there is 9 grams of water. So number of moles will be given mass divided by molar mass of water. So we have done questions based on this also. Any doubts in your class notes? Any doubt in any question you want to discuss? So we have done questions on this also. So basically number of moles, there are 2 formulas. Number of atoms, molecules or ions divided by Avogadro's number, and given mass in grams divided by molar mass of that substance, right? So moles, how will you calculate moles? From mass in grams. So mass to moles you can calculate. Then from moles you can calculate molecules, or you can call it particles. It can be molecules, atoms or ions, right? Now from molecules, atoms or ions, that is particles, you can calculate moles, and from moles you can calculate mass also. So we have done questions based on this also. Suppose there is 6.022 into 10 to the power 24 particles of water. So 6.022 into 10 to the power 24 molecules of water. So what is the mass of these molecules? So now particles is given, molecules are given. So first we will find out moles. Moles will be N by Na. So how many moles will be there? 10 moles will be there. Then we will be calculating mass. Mass will be number of moles into molecular weight. So mass is 180 grams. So we have done questions based on this. From particles we are calculating mass. From mass we are calculating particle. So in between you have to calculate moles. So from mass to moles, weight in grams divided by molecular weight. From moles to mass, so mass will be number of moles into molecular weight. So this will be the mass in grams. Then moles to particles, so number of particles is number of moles into Avogadro's number. From particles to moles, number of moles is number of particles divided by Avogadro's number. So all questions are based on this. Any doubt, any question you want to discuss? So you have to start the assignment from question number 11. From question number 11 till question number 35, not 35, 50. So from question number 11 to question number 50 are based on these formulas only. So these are the two formulas we are using in these questions. So till question number 50 are based on these formulas only, and ideal gas equation also. Come to question number 45. A quantity of 2 grams of triatomic gaseous element. So there is 2 grams of triatomic gaseous element, X3. Let the element be X. It is triatomic in the gaseous state. Like nitrogen is in the gaseous state is diatomic N2, oxygen O2, ozone is triatomic O3. So there is some element X which is triatomic in the gaseous state. Let the formula of the element be X, or symbol of that element be X, and the formula of that compound in the gaseous state will be X3. So 1 mole quantity of 2 grams of triatomic gaseous element was found to occupy a volume of 448 ml at 76 centimeter of mercury, that is 1 atmosphere, and temperature 273 Kelvin. So at 1 atmosphere and 273 Kelvin, what is the volume of 1 mole of an ideal gas? 22.4 liters. That is 22400 ml. Now, if the volume is this much, that means how many moles of the gas are there? So you can find out number of moles of the gas. So this will be 1 by 50. 1 by 50. So from volume, the number of moles of the gas you can find out, or you can use the ideal gas equation, PV is equal to nRT, and find out number of moles of the gas. So you can also use PV is equal to nRT, pressure you can take in atmosphere, temperature in Kelvin, volume is given in ml, convert this into liters, value of R will be 0.0821, from here you will get the number of moles. So we know at this pressure and temperature, volume of 1 mole of the gas is this STP condition. Volume of 1 mole of the gas is 22.4 liters. So using this, we are calculating the number of moles. So for this volume of the gas, what is the number of moles of the gas we have calculated? Till here, any doubts? Now, number of moles of the gas we know, that is 1 by 50. What is the formula of number of moles of the gas? Given mass in grams divided by molar mass. So what will be molar mass of this? 3x, where x is the mass of one atom. So mass of one atom or atomic mass is x. So 3x will be the molar mass, right? So weight is given as 2. So what will be x? 2 into 50 by 3, 100 by 3. So x is coming out to be 100 by 3. That means mass of one atom is how much? So this is atomic mass. So mass of one atom will be 100 by 3 AMU. Like atomic mass of carbon is 12. So mass of one atom of carbon, 12 AMU. Atomic mass of nitrogen is 14. So mass of one atom of nitrogen, 14 AMU. So that means question is asking the mass of each atom is, so mass of one atom will be 100 by 3 AMU, that is 33.3 AMU. Now look at the options. So first option is not the answer, right? Third option, C option is also not the answer. It is 33.3 AMU, not 33.3 grams. So this is 33.3 AMU, not grams. So C option is also not the answer. And D option is also not the answer. Till here, any doubts? Now for B option, what we have to do is change AMU into grams. So 1 AMU is 1 by NA grams. So using this, you can write down 100 by 3 AMU is 100 by 3 NA grams. So this is the mass in grams, right? So we are converting AMU into grams. So Na value you can take 6 into 10 to the power 23 grams. So this will be how much? 100 by 18 into 10 to the power minus 23 grams. So check, 100 by 18 is 5.53. Just check once. .53 it is coming, 100 by 18. So answer will be B option. The shape of tobacco mosaic virus TMV is cylindrical. So the shape of virus is cylindrical. Having length 3000 angstrom and diameter 170 angstrom. If the specific volume of the virus, so specific volume, what is specific volume? 1 upon density. So 1 upon density is specific volume, that is given 12.5 ml per gram. Then the molecular weight of virus you have to find out. So let us first find out the volume of virus. So volume of virus will be pi r square L. It is in the shape of cylinder. Pi d by 2 whole square L. So volume, first of all, you will find out in meters cube. Taking the length and diameter in meters, you will find out the volume in meters cube. Now this volume you will convert into ml. 1 meter cube is 10 to the power 6 ml or 10 to the power 6 centimeter cube. Now from volume in ml, you will find out the mass of one virus. So specific volume is given, that is 1 upon density is given. So from here you will find out the mass of one virus. So mass of one virus will be volume divided by specific density. So this will give me the, so volume over here we are taking in ml. So volume in ml divided by specific density, that will give me the mass of one virus in grams, right? So you have to find out the molecular mass of this virus. Let the molecular mass of this virus be X. So it is represented in AMU. So if the atomic mass of carbon is 12, the mass of one carbon atom is 12 AMU. Mass of 1 mole of carbon atom is 12 grams. So if the atomic mass of this virus is X, mass of 1 mole of this virus will be X grams. Mass of one virus will be X AMU. So now mass of one virus we have found out in grams. I suppose this is X AMU. Now X AMU will be how much grams? X by Na grams. So 1 AMU is 1 upon Na grams. So mass of one virus in grams should be X by Na grams. So from here you will find out the value of X. Now do. Cortisone is a molecular substance containing 21 atoms of carbon per molecule. So cortisone is there, that is having 21 carbon atoms per molecule. The mass percentage of carbon in cortisone is, so mass percentage of carbon is given. So how do you find out percentage composition? So mass percentage of carbon will be mass of carbon. There are 21 carbon atoms and mass of one carbon atom is 12. Divided by total mass of the cortisone. Let the molecular weight of the cortisone be mW, that we have to find out. So molecular mass of the cortisone be mW. So percentage of carbon will be mass of carbon divided by total molecular weight of the molecule into 100. So this will give me the percentage of carbon that is given in the question, 69.98. So you have to find out the molecular weight of cortisone. Find out. So molecular weight we have to find out. So percentage, what is the formula? Mass of carbon, there are 21 carbon atoms, mass of one carbon atom is 12, divided by total mass of the molecule, that is molecular weight that we have to find out, into 100. Percentage of carbon is given, molecular weight you have to find out.